Hello guys, so I decided to pre-record this entire live session video for you guys. So if you're absent today, so today's April 15, Thursday, or April 16, Friday, you can have this video, just email me. I think I mentioned this in Canvas. 8.5, drawing angle, that's what we did. And from now on, the topic's gonna be more difficult. We are going to deal with a lot of angles, radian, and then something called unit circle and trig functions next week. So I will record my live session video. So even you are in my class, if you have to re-watch or re-listen to some explanations or example or notes, feel free to ask me. I am happy to share this video with you. I am just not going to post on Canvas because I don't want to share with everyone. Okay? So today we did warm up, which is converting angle to pi in degree. So, as I explained on April 14 Wednesday video, whenever we have angle, we have two units, just like a Fahrenheit and Celsius whenever we are talking about the temperature. Every time we are talking about angle, you have two units, which is radian and degree. And we have to sometimes convert those two units. So now I have a 2 pi. Whenever you see pi symbol or pi sign, we are talking about radian. Okay, so 2 pi is in radian, and I have to convert that into degree. So we have to multiply by either pi over 180 or 180 over pi. Sometimes I cannot remember which one is which. So I'll show you the easiest one. 2 pi is basically 2 pi over 1, right? So to make my units into degree with a little circle, I should not have a pi, which means I am going to have a pi on the bottom so I can cancel this, and this will be always 180. So going radian to degree is you're multiplying by 180 over pi. If you have a degree and then if you want to convert that into radian, you just flip the fractions, which is pi over 180. So let's convert now. So 2 times 180 will be 360. 1 times this got canceled, so 1 times 1 is 1. So basically 360. So this means 2 pi is same as 360. And this is very useful. So please remember 2 pi is 360, which means half of 2 pi is pi, right? And half of 360 is how much? 180 degree. So this is kind of basic stuff that you kind of have to remember. So please remember 2 pi is 360 degree, pi is 180 degree. And this is how you convert units. Just multiply by 180 over pi or pi over 180, depends on your unit. Okay? Otherwise, you watch Wednesday video. I went over 2 examples there. Okay, so today we did 8.5 drawing angles, and then we learned something called reference and coterminal angles. Lesson goal I tell you guys to skip. We'll be able to understand the concept of the angle and find reference and coterminal angles today. And we have so many vocab words, like a new word. So we will write as we go through the notes. So make sure you make a good note, okay? So let's look at the angle. So definition of angle, a lot of people already know because we kind of did in geometry class, but let's refresh our memory. Angle is basically made up with 2 rays. Rays means like it's one direction. Usually it's arrow with one directions. 2 rays sharing common endpoint, or you can say vertex. Okay, so for example, this is one ray and it shares common endpoint or vertex, and then I have another ray. So I have 2 rays. And this part is angle, and this one is a vertex or endpoint. Okay, so we know about angle. We do 30 degree, 180 degree, 90 degree. Whenever we are talking about those, we are talking about the angle. So that's pretty simple. And a little bit new stuff. Something called the standard position of angle. So standard position means a angle drawn on the XY plane with a vertex at the origin and its initial side lies on the positive axis. So if you want, please pause the video and copy this. I'll show you what's going on here. We have X and Y plane in Algebra 2. And it says vertex at the origin, so which means origin is in the middle. We start at there. It has to be our vertex or end point. Initial side is where angle starts. It has to be on the positive x-axis. You know x-axis is this horizontal one, right? Which one is positive? It's always the right-hand side. This one is negative. So your initial side has to be on the positive axis, okay, like that. So this is your initial side, okay? Something called the terminal side, which is, where your angle stops. Let's just say your angle stops right here. Terminal side, it doesn't really matter where. Let me redraw. Okay, and let's label, this is your terminal side. Then we are talking about this angle. That's going to be your angle, right? Let me just draw this. And this is the standard position that we are talking about in math or algebra too. So angle, we have angle on the xy plane with vertex at the origin, right? And the initial side has to be on the positive x-axis. It cannot be on the y-axis. It cannot be on the negative x-axis. It always have to be positive x-axis. And terminal side, it doesn't really matter where, but always initial side on the positive axis, and we have to start at the vertex, which is origin. So this is the standard positions, right? And if you want to copy initial side and terminal side, the definitions is right here. Initial side, the ray where measurement of angle starts. It's simply where angle starts. Terminal side, where angle stops, okay? So you can pause video and copy. And I also went over a concept of quadrant. You don't have to copy if you already know. But, whenever we are talking about x and y plane, we have a 4-quadrant, right? Why 4-quadrant? Because we divide our x and y plane into 4 different positions. So usually it goes to the counterclockwise, okay? In science and math, counterclockwise is always positive. So the first quadrant is right here. This is the second quadrant, third quadrant, and fourth quadrant, all right? You don't have to copy if you already know. And then this x and y means basically your x and y, they both are positive in the first quadrant. For the second quadrant, as you see, x is negative number and y is still positive. That's why we have negative x and y. Third quadrant, everything is negative. And the fourth quadrant, my x is positive, right? 1, 2, 3, 4, 5. But then y coordinate is negative. So you guys have x comma negative y. So please try not to memorize it. Try to understand. All you have to remember is where is first quadrant, second quadrant, and third quadrant, and fourth quadrant. That's about it. Okay? Direction can be pretty critical whenever we are talking about angles. So let's go over the direction of angle. It's up to you to write down, but we do have a positive and negative angle in math and science. So we have xy coordinates as usual, and then we have a positive and negative angle. Let me go back here and then explain something I forgot. Full rotation of the circle is 360 degrees, right? So when you look at the quadrant and we divide everything by 4, you can do 360 divided by 4, but it's going to be 90 degrees. Right angle. This is right angle. So this is a 0 degree, but then here on the top is 90 degree because this angle is 90 degree. And if you add another 90 plus 90 is 180 degree, right? This is a straight line. Straight line is always 180 degree. And here, third quadrant, I have another 90. So 180 plus 90 will give you 270 degree. 270 plus 90 will be 360 degree. So hopefully you guys already know this. Please understand, whenever your angle is right here, it's like 90. Second quadrant, where the second quadrant ends, that's 180. This part is 180 to 270 degree, and this part is 270 to 360 degree. So that's where this angle came from, right? It's 0 to 90 degree, first quadrant. And second quadrant is 90 to 180, 180 to 270, and then fourth quadrant is 270 to 360. So if you want, please copy this. This is X and Y plane. Positive angle means your angle is counterclockwise. It's going this directions. Negative angle in science or math is clockwise, which means we're going this directions. See the difference? It's a clockwise, regular clock directions. Counterclock is we are going opposite from the regular clock directions. Okay, so please remember, I think positive angle is pretty easy. First quadrant is positive 0 to 90, right? But when you look at the negative, it flips a little bit. So we start from, I'll show you, here. It's still 0 degree. But whenever we are going to the bottom, clockwise directions, you guys have a negative number. So this is negative 90 degree. And from there to here is any degree between negative 90 to negative 180. So this is negative 180 degree. And on the top, we have negative 270 degree. So we kind of flip our 90 and 270. So please remember the directions. Okay. Make sure you're going to opposite directions. All right, so let's draw angles in standard position. So, for your homework, it's going to be multiple choice and you have to choose the correct answer or correct graph. So let's draw an angle with given measure in standard position. So now I have to draw 240 degrees. So first I will draw the X and Y plane, right? What did I say? This is 180 degree. This is 180 degree, right? I have to have a 240. So let's see where is 240. 180 plus 90, what did I say? This is 270. And this is 90. Let me just label it with red color so you see. And this is 0 or 360 degree, right? So you see that's 180, which means 240 is going to be somewhere here between 180 to 270. So 240 degree is this much. This is approximations. Okay, it's definitely bigger than 180, but definitely smaller than 270, and it's in third quadrant. There we go. Let's do negative number, negative 50 degree. So I still have X and Y. For negative, you're going to different directions, clockwise. So it's a 0 right here. This is negative 90 degree, if you remember. Negative 50 is supposed to be in between 0 and 90, right? Negative 90. So it's somewhere here. Okay, it's actually in fourth quadrant. Good, negative 50. Let's do 500. 500 can be a little bit tough. I know entire full rotation is 360 degree. Right? Still smaller than 500. So 360 plus 90 is 450, right? Let me erase this so you guys don't get confused. How did I get 450? I added 90 degree. And then 450 plus 90 will be, 540 degree. So 500 is supposed to be between 450 and 540. So I'll show you again. Let me just erase all. See? We start from 0, that's 180, 270, 360. But 500 should pass 450 and somewhere here. Okay, this is 500 degree. It's greater than 360, so we have one full rotations and then we go a little bit more. And it's actually in second quadrant. So that's how you draw the angle. Okay, everything is a standard positions, right? Because I start from the vertex, my initial side is on the positive x-axis, but my terminal side where angle stops is just either first or second or third or fourth quadrant. Terminal side, we don't care. Okay, so that's standard positions. Okay, we have something called coterminal angles. Let's copy this. So coterminal angle is angles which, drawing in standard positions, share a same or common terminal side. It's simply saying like same angles. Does it make sense? Same positions. So here I put example. I have a 50 degree right here. But another way to measure 50 degree, if you have another full rotations, you get the same positions. So 50 plus 360, I got 410. But as you see in this picture, 50 degree and 410 degree, it's same thing. It's exactly same angle with a different number. Why? Because we can add another rotations, right? Circle is like rotations. So let's do simple one. 0 degree and 360 degree, they are same thing. 0 plus 360 is 360. So we are coming back. Just like resetting something, resetting your phone, right? Whenever we reset something, like we just go back to the beginning, right? Same thing. So 50 degrees is this much, but if I add another full rotation of the circle, which is another 360 degree, you get same position, same angle. So basically saying 50 and 410 degree, they are identical. And which means coterminal angle, you can have a multiple coterminal angle. You can keep add 360, 360, 360, or you can subtract 360. So for example, 50 minus 360 will be how much? Negative 210, right? So negative 210, let me start from here. It's going this directions. Negative 210, oh, yeah, that's right. Negative 210 degree is also same thing as positive 50 degree. So, you can add 360 or subtract 360. If I tell you to find more, then you can keep adding. That was 410, right? You just add another 360, and that's going to be 770. So 770 is also same as 50 degree. You just keep subtract or add 360 degree. Pretty simple. So example here, I just gonna give you one example because it's pretty straightforward. Find one positive angle and one negative angle that are coterminal with a 30 degree. So what do you do? To find the positive, you're just gonna add 360. Boom, you're done. For the negative, I'll just subtract. 30 minus 360 is negative 330 degree. Boom, you're done. So it's saying 30 degree and 390 degree and then negative 330 degree, they are all same thing. Same position, same angle, same size, everything is same. Okay, so that's 30 degree. Let me draw for you. This is full rotation 360. Oops. Stop. But then we have another 30 degree to get the 390. So it's actually here. Right, same thing. And for the negative 330, I'm going the different directions. It's negative 180, negative 270, negative 330. See? Same positions. So it's called coterminal angles. Okay. Ooh. Today we learn a lot. One more topic, something called reference angle. So please pause the video and then copy the definitions. Reference angle is for any angle in standard positions, and it has to be acute angle with x-axis. Acute angle from the geometry is less than 90 degrees, so small angle. So here is example in the box I show you. First quadrant is usually the reference angle itself. So for example, if I say this is 30 degree, 30 is less than 90, right? So this is also your reference angle. So the angle and then reference angle are the same. Here, second quadrant, let's say this is 120 degree. So this is 120 degree, which is greater than 90. So this is not acute angle, right? But here, this part will be your reference angle. Okay, reference angle is always like you kind of stop at the x-axis and then look for the acute angle. So if that's 120, the blue one, how much is the red one? Straight line is 180, 180 minus 120. So reference angle in this case is 60 degree. Third quadrant is a little bit harder because a lot of people don't remember. This is 180 and this is 270. So let's just say this one was 250 degree. 250 is really big. Now I have to find this one. Okay. So now we are looking at kind of like y-axis, but it's stopped there. But anyway, it's going to be acute angle with x-axis. So this part. Oops, let me erase. Like this part. I'm sorry, x-axis, not y-axis. Okay, so my x-axis was here. I have a 250 degree, but when I look at the third quadrant, this part is my acute one, right? And how you find this, it's basically 180 minus 250, or you can do 180 minus 250, it's up to you. Let me calculate that. It should be 70 degree. Okay? Oops, why did I put negative 70? I'll show you the rules, the next slide. And then fourth quadrant is the last one. Let's look at it. Let's just assume this is like 300 degree, okay? You guys have 300 degree right here. And the reference angle, see this is your x-axis, right? So this part is supposed to be reference angle because it's a smaller than 90 degree. How you find? This one is pretty easy. It's 60 degree. You guys can tell, right? Because the entire circle has to be 360. So the rest will be 60 degrees. So basically, you're doing 360 minus whatever the angle is given. I'll show you. I'll show you the rules. Here, please copy this green box. That's the rule for reference angle. As I said, first quadrant is the easiest one. Reference angle and angle itself, they are just like same thing. Second quadrant, as we saw, if that's 120 degree, to find this acute reference angle, you do 180 minus the given angle. So 180 minus 120, you get 60 degree. Third quadrant, a lot of people are struggling. It's angle minus 180. So for example, if I say this is 250 degree, right? To find reference angle, which is overlapping in this case, 250 minus 180. So it will be 70 degree. Oops. Okay. And then the last one, reference angle, you are using 360, not 180 degree. So 360 minus angle. Sorry, somebody was stopped by in my room, so I had to pause video. So hopefully, yeah, I'll edit this, but you know, so the fourth quadrant I was explaining. So reference angle for fourth quadrant is pretty straightforward. You are not using 180, but it's 360 minus given angle. So for example, as I showed you earlier, if your angle was 300 degree, it's very obvious the reference angle is 60 degree because the full rotation of the circle has to be 360. So 360 minus 300, I got 60 degree. Okay, so that's reference angle. So let's practice. Find the reference angle of 170 degree. If I were you, I'll draw where is 170. 0, 90, 180, right? So 170 is pretty close to 180 degrees. So that's my 170 degree. It's in second quadrant. Second quadrant, what's the rule? 180 minus given angle. So 180 minus 70, this acute will be just 10 degree. So reference angle for 170 is, let me write down, 180 minus given angle, which is 10 degree. It's really small. Let's do negative angle because negative angle could be tricky. Let's draw the negative 30. So 0, and then, whenever we have negative directions, we are going this way, right? 30 is smaller than 90, so I'll draw the small angle. So this is negative 30 degree. This is negative 90. See, I know it's in fourth quadrant, but if you do 360 minus given angle 30, you will get something really big. It's not acute anymore. So whenever you guys have a negative angle, you kind of have to use the common sense / our rule. So just treat the fourth quadrant as our what's that called? The first quadrant. So look at the x-axis, which is this, right? See, this part is way bigger than 30 degree. So your reference angle in this case will be just 30 degree, just like the first quadrant. Whenever we were dealing with the first quadrant, whatever the angle is given there, it was our reference. So since 30 is way smaller than 150, right? Because the straight line has to be 180 degree. Let's do negative 150. Negative 30 will be your reference angle. Just make sure reference angle cannot be negative. So just take the absolute value. So the reference angle of negative 30 degree is just a positive 30 degree, okay? And a lot of people are wondering about the another negative angle. So let me do this one. Let's do negative 270 degree, or let's do negative 230 degree, okay? It's negative directions one more time, so I'm going this way. It's a little bit bigger than 180. So this is my negative 230 degree, right? I know it's on second quadrant. X-axis is right here. You have to find this one, all right? That's going to be a reference angle, acute. It's not going to be this one, okay? It's not that one. So in this case, what do you do is, straight line is 180, so you just subtract 180 with 230. Don't put negative 230. And that's going to be negative 50 degree. And just take the absolute value. Your reference angle is positive 50 degree. So it can be tough whenever we have negative reference angle. But I will go over a little bit more in pre-record video. But that's what we did in live lesson, guys, okay? So now you guys have to watch pre-record video, another video if you're absent, okay? And I put more examples, so please include that in your notebook and try by yourself and then submit 8.5 notebook. And number 2, 8.5 practice problem, I put 10 multiple choices questions, so please practice. And number 3, if you have any missing assignment or quiz, please complete. And that's it. All right, have a great weekend and I'll see you guys next week.